is the simplicity and the low maintenance. We don't have no nitrogen gas, no hydraulic accumulators, which with hydraulic accumulator, the accumulator itself is not a huge problem. It's got a bladder in it and it doesn't leak and you're pretty fair. But the problem is with those is that you run into multiple chambered cylinders, which means that you have internal piston packing within the cylinder. And so you're constantly, to change a large well, especially a large cylinder rather, on a large well, you've got to take the cylinder off, take it into the shop. Sometimes you got special tooling and so forth to disassemble it. So sure, you're down week, 2 weeks or whatever, and it can't be replaced in the field. Ours is very simple. Ours is not a regular hydraulic cylinder, it's a hydraulic ram, and I'll show you in an illustration in a minute. But we don't have any internal piston packing inside the cylinder at all, because all we do is we use the effective area of the rod as our total lift, and when we come up, so all we have is rod packing. And with the rod packing is replaceable. It's a split V. You can lower the unit with a hydraulic lift, move a gland out, replace the split V packing, put it back together, and I could probably do it in 30 minutes, but on a normal condition, you know, probably an hour and a half to completely replace the seals in this thing. We've got a chamber above the high pressure seals that any leakage from that, when it leaks, we almost immediately have leakage from our split V seals. It's a polyurethane type seals, they're not a regular like you see on a polish rod split V packing. But we have a small chamber up there that we actually lubricate the rod. The largest wear item on a hydraulic cylinder any place is the rod wiper, not the packing itself. And because it runs on sand and so forth, and the high pressure packing, if they're doing a good job, the rod is dry, and so the rod wipers running on a dry rod. This chamber allows us to do two things. It allows us to lubricate the rod wiper because it's in a little chamber under no pressure. We take a line back down to the reservoir through a jar sight glass, and it lets you know when the packing needs to be replaced. And so when it leaks, it's not going to leak on the ground. You can also, that sight glass allows you to evaluate and when you need to change the packing. I'm going to go right straight into the, can y'all see that okay? It's kind of hard to, yeah, I think so. But here's the basic concept of it and of the hydraulics, okay? Our system is, all it is electric motor, one hydraulic pump, and a hydraulic ram, okay? The ram has no piston seals. It's only a bearing that guides the rod within it, and it's lubricated, obviously, with oil in it. And the top is split V packing, urethane packing, that's field replaceable, and with a line back to the reservoir for any leakage in the small chamber. Our shivs on top are independent wheels. They can turn with it. They're not on a common shaft, and they're tapered roller bearing like individual wheels that the cables go over. And like I said, the 1 foot stroke relates to 2 foot on the actual polished rod load. So our pump, all we do is control the pump. Our microprocessor is connected directly to the control on the pump. And the pump senses four things, I'm sorry. It's got 4 sensors in it. It's got an RPM pulse pickup, it's got a pressure transducer, it's got a displacement sensor to tell what position the pump is actually in, and it's got a temperature sensor, okay? So if you have position, pressure, and speed, you can calculate horsepower. Very simple. So we know exactly how much horsepower is directly right on the shaft of that electric motor and whether it's a positive or negative. Okay? But the pump is a very simple, it's manufactured by Denison, Parker, Hannafin, so which is microprocessor based integral control on it. Another thing that we do, we don't use string pots or any other type of cabling system to get our position. This cylinder itself, we actually have a temposonic, what's called a temposonic sensor that goes right up through the center of the rod. Our rod, like it's a 5-inch diameter rod, we got a 1-inch hole through the rod, and our sensor goes up through that rod. So all of it's covered by the inside the cylinder itself and protected from rain or ice, snow, or from a workover crew or whatever tearing it off and getting caught in that. So it's all enclosed. That position allows us to, we can sense position within 10 or 15 thousandths of an inch. So now, because of that, we've got microprocessor control, we've got pressure, which is load. Area of cylinder to pressure equals the peak polish rod load and position. We can draw dyno cards off of this unit. We can take dyno cards. We can do a pump down, variable speed pump down control that we can match the inflow of the well to the pumping speed to the inflow of the well. This is an example of a small unit that was smaller units, easy to see, but